And welcome. In this video we are going to talk about model explainability. So we build a lot of ML models, supervised, unsupervised. So in case of supervised machine learning models, how do we explain a model? What are the different metrics of measurements we use on a day-to-day basis? So how do we bring all the metrics of measurement under the same umbrella? So let's see those things in this video. So what are the things do we cover? So first, let's get a data set, build an ML model that would be a classification model. And the third one, we explain the model with various metrics. So what are those metrics going to be? So the metrics which are generally followed for classification models would be accuracy. Then it is about confusion matrix. Of course, accuracy is part of confusion matrix. So then we will be having ROC AUC curve, and then we would be having charts, and the last one is about feature importance. So we have many features and we want to know which are the features contributing to an event or non-event. So these are the things which we will be covering in this video. So first, let's see the data set. So this is the UCI site, and from here we are going to pick a data set called as Raisin dataset. So I'm just clicking on this. I'll give this link in the description section of the video. So this has images of the Kesselman and Besney raisin varieties were obtained with CVS. Total 900 raisins were used. That is your number of observations, including 450 from both the varieties. So 450 from Kesselman and 450 from Besney. So this is pretty balanced data set. And so this particular one I have already downloaded, and let's see that Excel sheet. This is the data set which we will be using for our model. So I'm just zooming in a bit. So this has basically a lot of I think 7 features which all are numeric in nature. So it has the raisin related data like area, major axis length, minor axis length, eccentricity, and so on. And the last one is basically a class, the class to which the raisin belong to, that is Kesselman or Besney. So the first 450 observations are related to Kesselman, and the next 450 are belonging to Besney. So that starts from 452. So these are the 2 varieties of raisins. So this is what we will be working with. So let's get rid of this. And now let's go back to the the site again. So before we go to the Jupyter notebook and start writing the code, so let's talk about what is the library we are going to talk about, or which is the library we are going to use. So something called as explainer dashboard. So this is a very nice library which brings all the items we just spoke about under the same umbrella. So this basically installation is very simple. It's pip install explainer dashboard, and this has further modules like explainer, classifier explainer, and explainer dashboard, and just the model has to be run through this particular function. So it is very simple one. And then so this is basically an explanation of the explainer and the dashboard. So you will be having basically 5-6 tabs basing on what are the parameters we are providing, and it has all the different varieties which we will be seeing in a while. So this is the library which we are going to use, and this is something I would also provide in the documentation, in the description section of the video, and this is the documentation link. The GitHub link is here. So let's get the Jupyter notebook now. So the first thing, let's save this raisin model explainer, and then I would first import pandas for our data set. So let's get the data set. So this is my data set. So I would just say copy this. Okay. So pd.read_excel. This is an Excel file. So I got this, and let me store it something called this data frame. So this is done. So let's see if all the data has come properly. So let me just check the head. So this is fine. And then let me also see if, just for the sake, of checking the columns and so on. So this is the column names. So we have basically area, major axis length, minor axis length, all up to class. We have got everything here. So this is something like if you want to create a variable called as columns, this would be helpful. So we just printed it here. And then a very important point is in this, let's go back to the Excel probably class. If you see, the Kesselman and Besney varieties are basically completely sorted. That means first 450 observations belonging to Kesselman variety and the remaining belong to the Besney variety, but we do not want that. We want it to be shuffled properly. So what we can do, I would just say df.sample and frac equal to 1, and then reset index. I don't want old index, so I'll just say reset index, and I'll again store it back to the data frame. So this is fine. And now if we check, let me check the head basically. So now when we see, it has mix of all these items, right? So now this is good. So let me remove this. Then I need to basically divide this data frame into X and Y. So my X would be all these first 7 columns. So X would be dfi log, and I would say all the rows, and the columns would be 0 to 7. And my Y would be df, and I want only class. So this is what I would give. So let me check if X and Y have come properly. X, yes. And let me also check Y. I got that right. Okay, so we can take out. Next, we have to import a couple of libraries, and then we can go ahead and divide the data set to throw it into the model. So let me just get this explainer dashboard, import explainer classifier explainer. So I'll just remove this, and the other one is basically explainer dashboard. Yeah, I got that. And then let me import dash bootstrap components as dpc, then from dash import html, and from dash import dcc. And then I would say from xgboost import xgb classifier, since we are going to build a supervised model. And then from sklearn dot preprocessing import label encoder. That would be for our last, this particular one, it would be needed. And then from sklearn dot model selection import cross validation score, and then let me also import train and test split. So these are the libraries which are required for us. And then let me also do the encoding for this particular one. So I would say y class equal to y class, and as type, it is a bit slow, so I have to type sometimes and it keeps coming up. So category, and then I want to do this class cat equal to y class dot cat codes. So I am not overwriting, I'm just creating another class cat. So this is done. There is a small error, but yeah, we are good. We hide that. Then I basically now, if we check y head, I will be having two classes. I mean, two columns. But I don't want the first one. I want only the class category. So let me go ahead and I would say y equal to y class cat. I only want the second one. So let me just get that. Now we are good. Now next, I would go ahead and create train and test data set. So x train, x test, y train, and y test. And I will say train test split and x, y test size equal to 0.33. That means I want the test data set to be 1/3 of the total. Since we do not have different data sets, sometimes complete different test and train, if it is provided, then we don't have to do any kind of division. And random state I'm giving 55 and then stratify equal to y. So this is my train and test data division. So I'm good now. So next I'm going to use the model. So I would say XGB classifier dot fit, and I would fit it for x train and y train, and let me store this in something called as model. So this is something we are going to use it for classifier explainer. So I would say classifier explainer and model, which in turn would be for x test and y test. And this one, let me store it in something called as explainer. And then finally, I would say explainer dashboard. And that would be my explainer. So that would be this variable. And explainer. And then I need model summary. I would say true. And I need SHAP interaction. I would say true. And I was also say SHAP dependence. That also is true. And then let me give a title to this. And I would say model explainer for reason data set, and name would be dash just, and then let the description be dashboard. And in the end, I would say bootstrap equal to dbc dot themes. This is for our dashboard. And I would say cyborg. This is completely customizable. And I don't want what if analysis, so I'm just saying false. If that is all, that is also required to be part of the main the UI, then we can say that is true. And after all this, at the end, let me just say run. And let me just get this. So it is calculating all these items, sharp values, prediction, metrics, confusion matrix, classification, ROC, AOC curve, all these items it is calculating, and it is giving me at an endpoint for explainer dashboard, which I'm going to click now. Yes, so this is for a positive class. So whatever we are going to check here, this is for a class 1. And what are the different contributions? So the largest contributor towards class 1 is basically perimeter. And if we want to like zoom in, we should be able to zoom in and see, what are the values and so on. We should be able to zoom in and see. And if you just double click, it goes off, and hence so on for all the variables. We should be able to see what is the contribution. So that is step 1. So that is on the feature importance. Next is on the classification stat. So basically you need a cutoff to separate between positive and negative class. So here confusion matrix has also been given. So what we can do is Cutoff percentile for the samples, you see here it is bit overlapped the numbers. So the percentage is 42.1, and out of 900 the samples of 125 is being classified as are a true negative, right? So let me just drag this one, and we will be able to see all these values keep changing, and even for, the model performance metrics, they keep changing as we drag this one here and there. So for the first thing, let's get this accuracy. So now the accuracy is at 0.852, right? So let's get this from 0.5 to 0.75. So as you can see, the first thing is here it was 42.1 and now it is 44.4, and this was earlier 852, now it is 855, the slight improvement. So this we can keep changing here and there, and we should be able to see the values keep changing, and even reduce it further below zero point 0.5, and we should be able to see the values keep changing. So it is easier here than writing a bunch of code and checking every time how much what is the impact on the different classes. So this UI is far better. And further, what are the different plots we are going to get here? We are going to get the precision plot, the classification plot, and even further in this one as well, there are a lot of other things too, like precision, recall, F1, and so on. So in some use cases, accuracy is very important. People check that. In some cases, it is more balanced. F1 people check to measure the the performance of the model. In some cases, even log loss is very important to check. So it depends on what is the use case and what is the requirement. People can check different different metric. And as we keep coming down, it is on precision and classification plot. So at any given point of time, what is the cutoff and what is the percentage and so on the positive and negative class. So and then ROC curve as well, it has been given. So depending on what is the score, what is the cutoff we have given, and so on. So this ROC curve is also very comprehensive here. And then lift and gain charts, basically lift chart is here. So basing on model and what is the baseline and how good our model is performing, this is about it. This is about cumulative precision. So these are the bunch of charts they have given for classification statistics. Then comes our individual prediction. So we should be able to click and select some index, and we should be able to get the probability here. So let me get 135 or 313. I should be able to get the prediction here. And then it is about the contribution plot basically. So this is very similar to what we have seen in feature importance. So the same thing here. So perimeter is the largest contributor, and this is the average. So and it keeps on going as the number of features progress. So this is the largest contributor, perimeter. So this is about it. And these are a couple of statistics here. And then let's move on. We will talk about feature dependence. So this is about SHAP summary and SHAP dependence. So this is something we have already seen in the first tab, but this is very important. Say perimeter is most important feature for us, right? So is it dividing the data points properly? Yes, it is able to divide the data points properly. So, depending on what is the class is it contributing to, and we should be able to check the SHAP dependence here. So this is about it. So the red and blue color and contribution towards it, we should be able to see that. And if you want to zoom in to certain data points alone, probably we can do that, and just double click, we'll go back to the old one. And the last one is on the decision trees. So we should be able to generate, this is your displaying individual decision tree inside XGBoost. And finally, we should be able to generate the tree graph as well, but this takes time. The graph is library is needed, it's saying, and it takes time to generate the graph. It is not very quick here. So that is one observation, but yeah. So this has everything, all the metrics needed for a classification model's performance measurement. This has got everything. And further, this also can be downloaded. All the tabs we can download as a PDF, and we can store it on our local for future reference. So this is very nice library which has been built. So that's it. Thank you for watching.